Turkey Marathon! Welcome back, class. I'm Mr. Teacher with the SAT Math Video Guide, and let's finish up section number 5 of test number 2. So, number 16 says, a positive integer is said to be trifactorable if it is the product of 3 consecutive integers. How many positive integers less than 100, not less than 100, less than 1,000 are trifactorable? So, 3 consecutive numbers. We can start with 0, 1, and 2. If you multiply them, you get 0. And I'm kind of getting down to the point here because well, actually, let's start explaining a bit more. Let's get broad. I've been talking kind of confusingly. So 0 times 1 times 2 is going to be 0, but we need to find positive ones. So we know that's not going to work. But 1 times 2 times 3 is going to work, which is equal to 6. So this is working. Now, how about, well, there's negative numbers, right? So we need to test those as well. So -1 times -2 times -3. However, that's going to equal -6. So it's not working out. We just need positive ones. So we know that we can skip any negative consecutive integer. So let's keep going with this list really quickly. 2 times 3 times 4, which is 24. 3 times 4 times 5, which is 60. Then 4 times 5 times 6, which equals 120. And 5 times 6 times 7, which equals to 210, I believe. 6 times 7 times 8, which equals to, let me calculate this up, 336. 7 times 8 times 9. And the reason I'm doing this entire thing is because by the time you reach this problem, you should have enough time left to do all of these calculations. And I really do think you should have time by this moment because you will know you have done all the problems in enough time. So this is 720. We're getting close. Next one is 990. Okay, so that's basically the limit. That is the limit. It is the last number lower than 1,000. So let's count them up, and excluding this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 trifactors. Trifactorable, no? Yeah, it's trifactorable. There are 9 trifactorable numbers before 1,000. So that's not good at all. Give me just a second here. I'll edit it out and we'll start fresh again. Okay, we're back. Now, number 17. That really wasn't a good idea. I should have resetted the entire thing. But either way, number 17 is the cost of a telephone call using long-distance carrier A. Long-distance carrier A is $1 for any time up to and including 20 minutes. $1 for first 20 minutes. And 7 cents per minute thereafter. So 7 cents per minute afterwards. The cost using long-distance carrier B, actually, let's use a different color. Let's get creative. Cost of long carrier B is 6 cents per minute for any amount of time. So no other conditions on that. So for a call that lasts T minutes, I'm kind of getting sluggish here. For a call that lasts T minutes, the cost using carrier A is the same as the cost using carrier B. If T is a positive integer greater than 20, what is the value of T? Well, that's one very important thing right there. T has to be greater than T. But either way, on this problem, we need to write 2 equations. What are the 2 equations? One for the cost of using each one. So Okay, so let's write down the equation for carrier A. Actually, let's start with carrier B. And I'm writing in green again, but no, let's write with the nice blue that we had. So the equation for B will be equal to 6t for any amount. Let's call the cents as just a whole number, not a decimal. And for A is going to be a little bit confusing because it's $1 for the first 20 minutes. So let's take an example. What if the call was 35 minutes? Then what would happen is that you would have to subtract 20 minutes from that and you get 15 minutes. And that 15 minutes has been 7 cents for each minute. So an equation will look something like this. If we already said the cents are whole numbers, so we need to turn a dollar into 100. So 100 plus 7 times t, the total amount of minutes, minus 20. Because we subtracted 20 here. Let's imagine 35 was t for some reason. So we subtract 20, then multiply the entire thing by 7, because that'll be the remaining amount left. Now, we need to set these equal to each other and find out what t is. So that's not nice. Get away. So 6t is equal to 100 plus 7 times t minus 20. And then let's distribute that. 6t is equal to 100 plus 7t minus 140. Then you simplify. 6t is equal to 7t minus 40. And finally you get minus t is equal to minus 40. And therefore t is also equal to 40. So the amount of minutes for which the cost of carrier A will be equal to the cost of carrier B is 40 minutes. Flat. That's your answer. And we're done. No, I'm just kidding. We still have number 18 left. So we might as well do that right now. Number 18. Bold red. And there's some type of staircase here. Looks like a staircase. I will say it's a staircase. And there are... Okay, so 1 cube, 2 cube, okay. 1 cube, 2 cube, 3 cube, 4 cube. There we go. Let's just get rid of this. Actually, we don't even need to get rid of that. Actually, oh, let's get rid of some of it, so we know that's not part of it. So there we go. That's what it looks like. And then there's many lines that are thinner, which divide divide them into cells of cubes. So it looks something like that. Now, the figure above shows an arrangement of 10 squares, each with side of length k inches. Since they're squares, they're just like this. This is k inches, this is k inches. That's not a square, but you get the point. The perimeter of the figure is p inches. So basically the length of the entire bold line is equal to p inches. The area of the figure, which is this in each block, area is equal to area. Well, a inches. And the perimeter is equal to the area. So now we need to figure out, well, what is the value of k? K is the length of the squares. So what we need to do is we need to find the area in terms of k, and then the perimeter in terms of k as well. So, let's get started with area first. So let's put a heading here, area, and we'll do, let's do the perimeter later. So since each little square has sides of length k, 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 so they're all k, so the area of one square is going to be equal to k squared. Since there are 10 little boxes, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that was just intuition that told me 10 boxes. I don't know. But there are 10 boxes. So the area of 10 of these, which is the total area, is equal to 10k squared. So now the perimeter, perimeters. So let's make another header. There we go. So now we need to find the perimeter of one square. The perimeter of one square is going to be 4k, right? Right. So, but we don't need one square really, because this is an awkward stair-shaped figure. So we know that this is k, this is k, this is k, this is k. So one side is 4k. And then that's k, that's k, that's k, that's k. There's 8k. Now you count the ones on the little staircases. So 1, 2, 3, 4, 5, 6, 7. So 7 plus 8 plus 8. There's one more here. So lonely. So 8 plus 8. So it's 16. So the perimeter of the figure is equal to 16k. Now they said perimeter is equal to area, so we need to set 10k squared equal to 16k. And since this side is k squared and this is k, we can get rid of this k by dividing both sides by k. So if you divide 10k squared by k, there's the exponent rule that any integer x squared divided by x, you subtract the exponents of both 1. So the exponent of this is 1, so it's 2 minus 1, and you'll just get x to the power of 1. So k to the power of 2 divided by k is going to equal k. So 10k is equal to 16. The k on the right side just cancels itself out. Okay, so now we need to divide both sides by 10. So k is equal to 16 divided by 10, which is also 1.6. And if you want it in a fraction form, it is 8 divided by 5. Those are the two possible answers that you can give for this question. And so that's pretty much it. I will see you on section 8 of test number 2 very soon. Stay tuned for a Thanksgiving themed video, and I will see you next time.